Welcome back, everybody. Learning is a hobby here. I want to go over my solutions to the exercise set for section 5.1 in Tao's Analysis 1 book. So let me bring up my solutions. This will be a very short video because there's only 2 questions for this section, but we'll go through them nonetheless. Let me just bring up my solutions here. Okay. So question 5.1.1 asks us to prove lemma 5.1.15. Just to remind you of what that says, that's this lemma here, that Cauchy sequences are bounded. All right, and he does give a hint here. He says, use the fact that AN is eventually one steady and thus can be split into a finite sequence and a one steady sequence. Then use lemma 5.1.14 for the finite part. Lemma 5.1.14 says this. That's the the lemma that says finite sequences are bounded. Okay, note there is nothing special about the number 1 used here. Any other positive number would have sufficed, but why not pick 1? Okay, so all right, so here's my proof. Let AN, n going from 1 to infinity, be a Cauchy sequence. Then AN, n going from 1 to infinity, is eventually one steady. Then there is capital N in N, such that the distance between AJ and AK is less than or equal to 1 for all JK greater than or equal to N. Then that means AJ minus capital N is less than or equal to 1 for all J greater than or equal to N. And that implies that -1 is less than or equal to AJ minus AN, less than or equal to 1, which means that A capital N minus 1 less than or equal to AJ less than or equal to A capital N plus 1 implies the absolute value of AJ is bounded above by A capital N minus 1, or if A capital N plus 1 is bigger in magnitude, then it's bounded by that instead. Without loss of generality, let's just say that the second one is the case, just because that's a plus instead of a minus, but it doesn't really matter. For all J greater than or equal to N, then AN, N equals 1 to N capital N minus 1 is a finite sequence, and it's therefore bounded by some capital M greater than or equal to 0. Therefore, the absolute value of AN is less than or equal to M plus the absolute value of A capital N plus 1 for all natural numbers, all positive natural numbers. That implies that AN, n going from 1 to infinity, is bounded, and that proves proposition 5. What was it? 5.1.15. Yeah. Okay, and then question number 2 says this: if AN, n going from 1 to infinity, and BN, n going from 1 to infinity are bounded sequences, show that AN plus BN, n going from 1 to infinity, AN minus BN, n going from 1 to infinity, and AN times BN, n going from 1 to infinity are also bounded. All right, so here's the proof. Let AN, n going from 1 to infinity, BN, n going from 1 to infinity be bounded sequences. Then there are M prime greater than 0, such that absolute value of AN less than or equal to capital M, and absolute value of BN less than or equal to capital M prime for all n greater than or equal to 1. Then I just broke it up into 2 cases. The absolute value of AN plus or minus BN is less than or equal to the absolute value of AN plus the absolute value of BN by the triangle inequality, which is less than or equal to M plus M prime. Here I just said by the triangle inequality, which implies that the absolute value of AN plus minus BN is less than or equal to M plus M prime for all n greater than or equal to 1, which implies that both of those sequences are bounded. Okay, and then same idea for part 2, except we don't have to use the triangle inequality here. Absolute value of AN times BN is equal to the absolute value of AN times the absolute value of BN, which is less than or equal to M times M prime, because all those numbers are positive, right? Or 0 for all n greater than or equal to 1, which implies that the sequence of AN times BN as n goes from 1 to infinity is bounded. And that's it. That's the proof of it's very, like I said, very short exercise set. So I'll stop the screen share. I'll see you guys in the next video, which will be the summary for section 5.2. That the solution set for that exercise set is also short. I think there's only 2 problems for that one too. But next video will be the summary for section 5.2. I'll see you guys then. Until that time, keep learning, and like I said, like I always say, let me know what you think down below, and I'll see you guys soon.